So when I look at the HDF community, I would give you this metaphor, which is that of radar. When I look at the HDF community and try to draw any kind of conclusions, it's like inference based on uncertain information. And so like we all know how radar works, basically you emit packets of energy, and then you listen sort of what comes back. And you have a receiver. And so in our case, the senders, the sources of energy that we have are software releases, community project software releases, outreach activities that we do. And then on the receiving side, we are listening to, well, you can look at Google Scholar. That's actually something I do every week because I enjoy it. It's amazing. So if you search all-time Google Scholar just for HDF5, you get about 20,600 citations. And that number is growing by about between 60 and 120 every week. So year to date, 957 citations. It might be more. I did that search maybe yesterday or 2 days ago. And then of course, the forum is always fun. Pull requests that we receive, bug reports, of course, help desk questions. So those are the kinds of senders and receivers. And so we try to make inferences or try to understand, get our head around what is it that people want, in addition to, of course, talking to people and so forth. Just the HDF group as an organization and some of the overlaps with what Dana said already, you can basically ask, well, what is it that we are doing? Why are we doing it? And how are we trying to make it work? And I'm not going to read it for you, but the idea is basically, yeah, our goal has always been, and I think will always be, make large complex data manageable, efficiently accessible, anywhere and indefinitely. And I'll explain what I mean by anywhere and indefinitely in a moment. Why are we doing it? Well, a lot of us are either ex-scientists or practicing scientists or engineers, and definitely want to help communities of researchers, advanced science and engineering. And then, yes, for our company type commercial users, we want to help them also make better data-driven decisions faster. And we do that maintaining some of our core products and adding value to this community ecosystem. And we complement this with support services, training services, development, consulting, and so forth, that we use to, at the end of the day, raise the funds to continue to innovate and so forth. There's a lot of mythology out. I'm going to skip that slide. Dana touched upon that already a little bit, so I'm going to skip that. Signals. So I put these together also based on some of the things that I heard in the discussions over the days so far. In the area of that I would describe as language bindings and modules, there's obviously an increasing demand for streaming capabilities. If you talk to some people, they would say, well, what is streaming HDF5? Isn't Swimmer streaming HDF5? Well, Swimmer is a very narrow use case of what you might call streaming, but in my opinion, there's a lot more to streaming HDF5 than Swimmer. And then obviously concurrency is a hot topic. Besides having high quality sort of idiomatic modules and language bindings, I think it's also not misguided to think about what I would call API-less HDF5, or take that a step further to think about, if you think about the history of I/O, it's in a way an artifact of the Unix development, that distinction between sort of character I/O and block I/O and so forth. And then there was always this difference between RAM that gave you random access and sort of block devices that gave you block access. But now with persistent memory, for example, you can access it like RAM, but you also get the persistence. You can access it like a block device. So all of a sudden, that dividing wall is gone. And maybe it's time to think about that user I/O really should be removed from what users should have to worry about. And yeah, so but that's a longer and more radical thing. But then by thinking about it, we are just showing that we are trying to be honest brokers. We don't want to work ourselves out of a job intentionally, but got to start thinking about these. Tools, we talked about TypeScript-based pure/plugins, definitely H5 Web, H5 WASM, the VS Code plugin. I think this is something that we will pay a lot of attention to and support this in any shape or form we can. On the flip side of that, the file format is not going away. So we have no illusions about that. In a way, I think we're going to double down on that in the sense of really, I always like to use the example that if you look at the earliest version of the file format specification, there are certain elements in there like ASCII strings, for a symbol table or global heap or local heap. There are these ASCII strings like G, L heap and whatnot. And the specification actually says, oh yeah, this is in support of forensic tools to make repair of corrupted file easier. Yeah, sure. But these tools never materialized. So I think 25 years should be long enough to now make an earnest effort and really deliver on these tools. And I think we will do that, provided we can find the resources for it. And on the other hand, just a recent discussion on the forum, there was someone, I believe in Austria, who had some very important data that somehow was rendered inaccessible. And a interesting outreach comment, didn't know that HDF5 was open source, that the file format specification was open. But obviously, this was a very talented person because we pointed him at the specification and said, hey, if you want to invest the blood, sweat, and tears, you can go back to the specification and see what's there, if that data is important. Or you can hire us. Chose to do it himself, and he actually succeeded. And so I think it was a great success story in the sense that sure, our documentation can be improved, but it was obviously sufficient for him to really go down to the bytes on disk and recover his data. And the interesting thing was also going back to FAIR principles in the simplest incarnation. He also had decorated his data sets, for example, with time step information, because in his case, it looked like basically the link names, the symbol table of the root group got corrupted. And I pointed that out to him and said, you may be able to recover the data, but you may not be able to infer which is which. But he said, well, as long as the timestamp attribute act, I can tell who is who. And so he was able to recover all that, and happy ending. So I thought that was a great story. Standards, yeah, definitely. It was interesting to see that, yeah, FAIR. I mean, we have been exposed to all kinds of standardization efforts, metadata conventions, and so forth. But it's great to see that has now sort of much stronger support in the scientific community and elsewhere. And we definitely, if there's anything as HDF group, as the stewards of this ecosystem for the time being, we can do to support that, to automate that, to make that easier, talk to us about it, and we'll definitely give it some thought. And then on the money side, sure, we are always looking to find resources to fund this. And yes, if you have an idea, and we started ourselves to look at a lot of private foundations offer research grants or other grants, even open source support grants. So we are definitely working on that. I mentioned anywhere and indefinitely. So I think historically we pride ourselves that, yeah, HDF is basically anywhere. And historically that meant, well, maybe your notebook, your department server, your HPC system, but now there are things like cloud, there are edge devices and so forth. And yeah, we are not going to stop there. I mean, we definitely want to be there. And that's part of keeping HDF relevant. But I think what we also want to pay close attention to is that thing, HDF5, cannot be bits and pieces of technology that certain people who are tuned into one platform understand, and then people to another tuned into another platform see something completely different. It is important to create that cohesive appearance that everybody who looks at this says, yeah, this is HDF5. And a good example of that is what I would call HDF Turing test, which is what John has done with HSDS and H5Pi. Well, it's like duck typing in Python, for example. If you can take a Python script that imports the H5Pi module and run it, and you get a result, and then you just do import H5Pi-D as H5Pi, and it produces the same result, I would call this is the Turing test. So what you are talking to is obviously HDF5. So I'm talking at that level. I'm not going to talk about, we heard examples of the virtual object layer. I think that is very important here. Another thing, and Lucas, I think, did some great first strides in that direction, is really also in the DOE space and so forth. We are seeing this, I'm going to dramatize it here, the twilight of the general purpose processor. I mean, we know that's what killed DEC and made Intel great, the introduction of the general purpose processor. But we are seeing many vendors, including storage vendors, they are putting processing capabilities into memory, like fabric connected RAM and all these devices, processing in memory, smart storage, Samsung, for example. And we want to support that. I think this is another element that we've always prided ourselves with, is to shield users from these technology changes that it looks and feels like HDF5, no API changes, but we will do everything to bring these capabilities to you, to let you take advantage of them without having to change anything in your code. And Dana also talked about HDF5.2. One thing is, of course, the whole refactoring and so forth, and definitely for our production capabilities, that's front and center. But on the research side, I think this is also an opportunity to create something what I would call the HDFX testbed, and I just chose HDFX because I didn't have a better idea. And but basically try to slim down HDF5 and start reasoning about what is really essential to HDF5. Is it really just a sorted key value store, if you wish, plus high concurrency, plus asynchrony, plus certain atomicity characteristics, maybe support for closures and streaming. So if we can get funding sort of on a more researchy background, I think this is something worthwhile investigating, and it will actually cut both ways. It will tell us what's going to happen beyond exascale, where these things will be important, but it's also going to help us as we want to go edge devices, maybe to the more microcontroller level. This is going to be interesting. They are having that kind of test bed, and then also working with maybe hardware synthesis tools, LLVM sort of compiler technology and so forth. So these are directions we are also looking into. And then HDF indefinitely, HDF5 as it stands right now from a digital archival perspective is only conditionally suitable for archival. And if you are interested, this is a long topic. We can talk about that. I always like the idea of, like the PDF guys, the printing industry realized that they created PDF-A, and I think we should have a similar standard like that called HDF-A, for lack of a better idea. And what that means is we would have to pay attention to bit level reproducibility, and that includes the HDF5 file, but it also includes library versions, compiler versions, and so forth. And fortunately, things like GNU Geeks, they have solved this problem for Bitcoin and others. So this is technology we can just take off the shelf and create something like that. We should definitely have, I mean, having a human readable specification is okay, but I think we need sort of what I would call a machine digestible specification. I wouldn't go as far as saying, well, you could train a neural net to learn the HDF5 file specification. It's probably possible, but I still would have sort of a degree of unease, even if somebody showed me something like this. And then take that to the next level where we have that basic serialization, deserialization layer for the file format auto-generated. Just no human in the loop. It's just something that you can create auto. And this is all stuff that's possible today with technology that we understand and that's robust. It's really just a serious engineering task. And then together, as part of that specification, really have that's important for digital archival is to have different onions, compatibility layers or risk layers that tell you, well, you can use that HDF5 feature, but it has the following impact on the archivability. So plugin dependencies, for example, or certain features in the file format that put you at a certain higher risk. Power of linkage, I'm not going to talk about it. Automation, yeah, how can we simplify plugin management and so forth? This is definitely something that's important, but also in the context of archival. And then there was just a post the other day, FlatHub, yeah, is an interesting model to look at how we distribute software that maybe we get away from this distribution and that distribution and whatnot and really create a more unified packaging. And we talked about FAIR already, and I think that was it, and my 15 minutes are up too. Yeah, and we can discuss this more tomorrow. We want to talk about what are we missing. Just to come back to the radar analogy, there might be missing bands, there are stealth objects out there and UFOs maybe, jammers. And but I think with respect to the community, what is so important is really the information flow between radar sites. I mean, radar, an area defense system, is a collaborative system where all the actors can act independently, but the real power unfolds when they act together and coordinate in certain ways. And I think, like in this group, I think we have great communication, but I think we want to strengthen that and enhance it in any shape or form we can. Okay, good. 15 minutes, run for the bus.